My name is Adam Watson. I'm with the Washington County Extension Office. I'm our ag agent currently. And this evening we have two speakers. I think I'll just ask for each of them to introduce themselves as they do their presentation. So we'll begin with Dr. Forbes Walker. Again, thank you for joining us on this webinar. This is a webinar that is an outgrowth of research and efforts that UT has towards recovery from Helene. So we all know the number of farms that were impacted across the region, not just in Washington County. And this is just an attempt to help connect folks to the specialists that are doing some of that research that will help us bounce back faster. So with that, Dr. Walker, if you'll go ahead and begin.
Okay, well, thank you very much. So my name is Forbes Walker. I'm environmental soil specialist here at the University of Tennessee. Been doing a lot of work in recent months in the Nolichucky area, and we wanted to update you on some of the information, the data that we've collected. So with me tonight, we've got Bruno, who is the our forage specialist, as well as David McIntosh, who's been a great help. David's a long-term resident of the area, so he's been very critical in helping us out. So I'm going to try and share my screen if I can. It's not letting me do it now. So can everyone see my screen here?
Yes.
Okay. So we're going to talk about some of the things that we've been doing after the flood. As a can't seem to advance this. Let's see. Oh, there we go. So overview of the presentation. Talk a little bit about the size and the scale of Helene. A little bit talk about the damage that we've experienced in agriculture. Some of the fact sheets that we put out, and then talk about some of the things that we're learning about how to deal with some of the sediments and the rocks that we're dealing with, some of the analyses that we've collected, as well as some of the results from a germination test spot experiments that we've been doing in Greenville, and then talk a little bit about some of the future field tests. This is going to be what Bruno is going to be focusing mainly on, as well as some concerns we've got about some stream bank stabilization concerns. So let's quickly go to Helene. So Helene, we all know there was lots of rain in Tennessee. This is a map here from the Tennessee Climate Office at Eastern Tennessee State University. You can see on the Nolichucky side of things, we're at about 5 or 6 inches of rain. But you go to some of the North Carolina side, there's a whole lot more rain on the North Carolina side, and that's really what caused a lot of the issues. Nolichucky is actually a Cherokee word that means raging river, so it shouldn't be any surprise that this has happened. And in the last couple of 100 years, we know there's been some fairly significant floods dating back to 1824, 1867, 1901, 1916, 1977, and the big one was the one that we've just had in 2024. Just to show you the scale of some of the flooding, this is a gravestone from Ebenezer Church right on the banks of the Nolichucky. And Sarah North died in 1807, and you can see half of her headstone has been covered over by the silty deposits there. So that shows you that in the last 200 years, this was a big event. We put out a couple of fact sheets. This is a fact sheet that Bruno put out with Gary Bates, talking about how we handle challenges with pasture and hay. These things are readily available. Obviously, things to do with flooded pasture, removing debris, keeping cattle out. This is all past now. Obviously, if we've got hay that was flooded, we don't want to feed it, and some other things there. And reseeding. So this is what we're going to be talking about towards the end. What are suggested things for reseeding some of these pastures? This is another publication we put out about post-flooding soil management, how to get different assistance, and how we deal with some of the sediments. Dealing with rock, so for the most part, Nolichucky was not really impacted by rock. This is a photograph that Kathleen and in Carter County shared with me, but Carter County had things like rock and how we deal with that. Obviously, FSA is there to assist. They're suggesting taking lots of photographs, remove these rocks if possible, assess what kind of soils have you got left underneath these things, soil test, keep lots of records of the time as well as the money spent. Most of the things that we're dealing with are sediments. So if you go back to our basic soil science, soil is made up of three different types of particle sizes. The larger ones are the sand size, followed by the silt, followed by the clay. And what happened as the river moved onto fields, the larger particle sizes, the sands will fall out first. And if that water stays around for a long time, then you start to get the silt deposited. Clays will remain in suspension for quite a long time. So we rarely see any clay deposits. A lot of those clays, once the flooding passed, were floating on down the river towards Douglas Lake. Typically, we see sandier type deposits near the river. These obviously drain much more quickly. They are also tend to be lower in nutrients. We'll share with you some of the things that we're finding about the nutrient content of these different sediments. Silts, we typically find the silt deposits further away from the river. Some fields or many fields that have got silt deposits, we still cannot get on there. What happens is they dry out from the top, but they're still wet underneath, and you will get equipment stuck very easily. So managing the sediments, the first question a lot of people ask for, how do we manage these sediments? The big question is, we don't really know where the sediments came from. They could be coming from a mile upstream or 100 miles away, depending on where you are. What's in them? We've done a lot of analysis of what the nutrient content is in them. We've looked at, what kind of pHs we've got. We've tried to, there's anecdotes of fuel spills. We've not actually tested and found those. That's probably dissipated by now. Pathogens were a concern early on, but the pathogen potential has long gone, because so we're about 5 months after the flood. We do suspect there are some pesticides in some of these sediments. We'll talk about that later. And then one of the things that we really are concerned about is erosion control, especially on these silts. You can see a photograph here of a silt deposit. Nothing grows on them. Basically, there's no seeds in these sediments, so there's no weeds are growing. This is a picture of a farm outside of Irwin, and you can see in the foreground lots of silt deposits, and in the background there's lots of sand deposits. So this depends on each field. We have to read differently as to how did the water move on, how did the water leave. And so this is a particularly badly impacted farm. They had over 200 acres with about 6 feet of sand deposited, and you can see the kind of mess that has created. Silts, that's another common thing. This is on the same farm, different part of the farm. You can see, yes, there's 1 or 2 weeds growing, but not very much to talk about. Lots of algae on the surface. And this is something we're going to be talking about, how we get on to actually put seed on these types of silts when we can't actually get equipment on the area. So from our sediment analyses, and we've collected as many sediments as we possibly can, the results are surprisingly good. The pH seems to be pretty good. So I'll show you a table after this, that the pH seems to be around 6.5, which is ideal for growing things on. We have low to medium or low to high phosphorus and potassium. We do tend to be low in micronutrients as boron. So if we're going into vegetable production, that may be an issue. We are surprisingly high in copper and zinc, which is good news, because we do need these nutrients, and surprisingly high in the organic matter. A lot of this organic matter would have come from the vegetation that was mixed with the different soil particles before they were deposited, and typically we're seeing the silts having a 6 to 10% organic matter range, whereas the sand tends to be lower. The question is, how long is this organic matter going to stay for? It's not going to be the more persistent or soil organic matter we're getting. It's going to be it'll be used up very quickly by the microbes once we start to get things growing. This is a chart showing some of the samples. So if you look at the second column on the left there, you see the water pH. You see pH 6.7, 6.9s, 6.5s. Moving over to the phosphorus rating, we see M's, medium, highs, and a few lows there. So that's kind of good news for us there. Similarly, the potassium ratings, we have some low potassium soils, but also some medium and some high. So surprisingly, a good amount of phosphorus and potassium in there. We go to the far end, the last column on that slide. You can see the organic matter, and the organic matter very much depends on what the soil texture is. Obviously, the sandier soils, the lower the organic matter, the more silts we've got, the higher the organic matter content. There was a lot of concerns about heavy metals in the sediments, so we had these tested in the University of Georgia. You can see some of the elements there: the aluminum, the arsenic, boron, calcium, cadmium, chromium, copper, iron, potassium, magnesium, manganese, molybdenum, sodium, nickel, phosphorus, lead, and sulfur and zinc. We did these analyses, and we then compared them with a publication that the University of Tennessee put out back in 1997, where they looked at the total elemental analysis of different soil profiles in Tennessee. The nearest we had was a soil profile in Granger County, also on an alluvial stream terrace. And by comparing the results of the test that we got out of University of Georgia with what was in this publication, we are seeing slightly higher chromium levels, but compared with US averages, it's lower. So that's not a concern. The zinc appears to be higher, which is a good thing. We need zinc. It's an important micronutrient. The manganese and the sodium seems to be lower. The fact that we got low sodium doesn't seem to be a problem, but the manganese, the manganese is an important micronutrient. We typically don't see micronutrient deficiencies in Tennessee of these because it's typically found in sandy deposits or sandy soils. Now we've got sandy soils, so this may be something we may need to correct, especially if we're looking at growing some high value crops. We collected a lot of these sediments, and then we basically ran some greenhouse studies at the station in Greenville. We basically said, okay, what do we grow along the Nolichucky? What kind of typical forage crops? What kind of typical vegetable crops? What kind of row crops? What other things? So we did some germination tests, and we then, after the germination tests, we actually grew the plants in larger pots to see what would happen once they had established in these sediments. So germination rates after 31 days. It's disappointing to see what we couldn't get any tall fescue and orchard grass growing. This is something that Bruno is going to be talking about later, some of the ideas we've got there. Some of the larger seeded crops like soybean and corn grew, they germinated very well, as did some of the things like oats and wheat, which is good news for us. And then you can see some of the numbers there for some of the vegetable crops. The pumpkins did pretty well. Watermelon did pretty well. The challenge then is once they've germinated and then they get established in the sediments, are there any other problems that we're likely to encounter? And so some of the things that we were suggesting that folks do, first of all, you're not allowed to push these sediments back into the river. I know they came from the river, but we can't push them back in. We are encouraging people to test your sediments to find out what the nutrient content is. The soil test lab in Nashville has amended our forms where you can tick a box to say these are from flooded fields. These tests are going to be free, and so we encourage people to do that so that you know what kind of pH, what kind of nutrients you do have in these sediments in terms of growing. We're going to talk a little bit about some of the other things that we can do. One of the other simple tests I think we would like people to start doing is collecting some of the sediments in a pot and growing some green beans to see how those green beans germinate, and then see what kind of symptoms once they've established, whether we're seeing some strange looking leaves or in the with the green beans. We're really, with recent rains, we're really concerned about the amount of erosion that we're seeing, and where possible, we'd like to see, if you're not growing anything at the moment, to see some things like any spoiled hay or wood chips on that surface. Obviously, we got we don't want livestock on those fields, until at least 30 days after the event. That's passed. We don't want to feed the flooded hay. We're suggesting maybe using that for erosion control. And for the vegetable crops, we weren't able to harvest these flooded vegetables or plant 60 days after the flood. That's all passed now. This is an analysis of the Nolichucky River. The Nolichucky River obviously flows from the west to the east. You can see it's about 118 miles long. We've done some analysis to find out what is the land use within that Nolichucky River. And if you look at land use within a mile of the Nolichucky, dominated by forages, 45,000 acres, over 45,000 acres within a mile of the Nolichucky along that 118-mile stretch of the river. In terms of row crops, we've got about 7,500 acres of row crops, kind of split almost evenly between the soybeans and the corn. Obviously, people that are growing row crops are in the corn-soybean rotation. And then you can see the vegetables. While it's not a very big area, it's a little over 550 acres. These are really high-value crops. They support a lot of, they require a lot of labor, so that they're very important to the economy of the region. So that's interesting stuff to learn about from that GIS analysis. Our greenhouse studies. I'm going to talk quickly about possible residual herbicides. So we are suspecting that we've got some aminopyralid damage. This is a broadleaf herbicide commonly used on pastures. Grazon is one of the products. And we're seeing some symptoms of herbicide damage, especially on some of our sensitive plants, things like beans, squash, and soybean. We did a lot of testing, spent a lot of money. We sent samples to Mississippi State. We were not able to detect any of this herbicide. We did find out later that the detection levels, the lowest they can go is at 6 parts per billion. Recent studies from the University of Georgia have found damage to beans and squash at the 1 part per billion level. So the fact that we can't detect it with the current lab tests doesn't mean to say it's not there and it's not a concern. I've already mentioned we didn't have any heavy metal concerns. We do suspect some micronutrient deficiencies, especially boron and manganese in some of the vegetable crops. I'm quickly going to show some pictures and then Bruno, hand this over to Bruno, but you can see some of the bean plants. This is the common bean, or green beans. You can see that plant in the lower left, the kind of curling of the leaves, crinkling of the leaves, looks like it may be herbicide damage. Just to show you, with these pots, we had the left-hand row is the pots where we had straw on the surface to try and keep that moisture up to prevent the plants the soil from crusting over. Nothing in the middle. And then we tried with biochar, which is a material that we know will actually hold moisture and potentially say. But you can see from this particular plant, these beans, there's obviously some disease. There's obviously some micronutrient deficiencies. You see that pot in the middle, as well as some potential herbicide damage. This is corn plots again, same. The straw, the nothing, and the biochar. You can see some fairly sick-looking corn plants with some obvious nutrient deficiencies going on there. Soybeans. The soybeans, remember, they emerge pretty well, but then once they start to establish, then we run into all sorts of potential micronutrient deficiencies or it could be some of this residual herbicide stuff. You can see some fairly sick plants there with obviously some issues to see. Pumpkin, this is a pumpkin seedlings that we did pretty well. We were quite impressed that we actually got one to flower. When we talked to our vegetable specialist, and he said, no, that's not a good sign. This should not be flowering at this stage. This plant is stressed. So while we may be able to grow these things, we may not be able to get them to fruit at the appropriate time. Watermelon, similar story. You can see a lot of the pots, the watermelons emerged pretty well, but then they died later on. I'm not going to dwell much on this, but you can see oats came up very well, especially if you've got it covered with straw. Similar story with wheat. Bruno's going to be talking a little bit more about these things later. Ryegrass, similar story. So these larger seeded things do seem to germinate and do quite well. We mentioned earlier on that we couldn't get any fescue or orchard grass. This is an experiment where we increased the seeding rate, and if we increased the seeding rate, we could get it to germinate. And again, Bruno will talk about that. Same story with the fescue. The control. Basically, we said, will anything grow? And you can see nothing, not even weeds were able to emerge from there. So that tells us there's no seed around. We're going to have to seed this stuff. This is some of our travels along the Nolichucky. We did not try any brassicas, but we saw this volunteer brassica on a sandy thing by the side of the river. So that shows you that brassicas will grow. We are seeing the emergence of some sinkholes in some areas. So that's another concern that we have to be aware of. This is a sinkhole that opened up overnight and went from, being level ground to 30 feet, big hole in the ground. This is another interesting thing. This is a road cut outside of Irwin, near the old quarry slash landfill, and you can see this silt layer that was buried, about 8 or 9 feet down. We actually took a sample from it, and you can see, and we had it radiocarbon analyzed, and it came out that this layer was put down in 1300 AD. So you can see there's a silt layer, and above that is some rocks. That's obviously where the riverbed reformed, and then another silt layer, more rocks. What's going on there is successive floods, and it's interesting to note that nothing grew in that silt layer. Obviously, they weren't going around seeding it. We're going to have some talk. Bruno's got some ideas about what we might do to seed that. This is a trip that David and I took last week just to see what's going on. This is just off the Fish Hatchery Road in Greene County, and this is the same field. You see that slide on the top. This was some sediment that had not been seeded, and horrible erosion going on. In the lower photograph, they planted some ryegrass. You can see it's come up. It's not the best stand of ryegrass, but at least it's offering some sort of protection. So we're going to, in this coming season, we're going to have to plant something on these sediments, or at least cover them with wood chips, hay, or straw to prevent erosion. You'll notice in that bottom picture there's also seems to be a kind of bare patch. So the seedlings are germinated, but for some reason something has happened. We don't know what the cause of that is, whether it's potential pesticide damage, localized pesticide damage, or whether it's just because of the physical properties of the sediment or something else. Other things that we have concerns about, we've got crews going around a lot, removing a lot of the woody debris. You can see that photograph on the upper right. That's in the upper part of the Nolichucky, just outside of Greenville. That stream bank would have been vegetated with lots of trees. It's now no longer vegetated with lots of trees. And you can see the photograph underneath that. This is a common practice. Where we had tree-lined riverbanks protecting the riverbank, the woody debris has all been removed, and we're causing all sorts of erosion problems. That photograph on the lower left, you can see what happens when you don't have anything protecting the surface. It's common to see cuts in the riverbank. So if the trees have been removed, one of the things that we're suggesting is trying to get hold of some of these wood chips that the debris removal companies have got, and at least applying them along the riverbank to offer some sort of protection from erosion. And with that, I am going to pass on to Bruno. So I'm going to stop sharing and hear what Bruno has to say.
Can you guys hear me and see my screen as well?
Yes,
Yes.
sir.
Good. Awesome. So thanks so much, Forbes and Adam, to put this together here. Forbes already helped me a lot with this overview of the whole situation. Uh, what I will try to show you guys here is what we learned in the last few months, trying to work with those sediments and with the greenhouse trials we have very focused on the pastry side of it, right? Forbes already mentioned we have several acres in hay fields that used to be close to the river there, and we need to find a way to bring it back to what it was in the past, right? And on this, I I have three main points that I want to touch here. Uh, uh, Forbes already mentioned about the area evaluation, but I want to give you a few of my thoughts on this. And then the greenhouse trials, and then what I'm calling the recovery plan for hay fields or pasture areas, right? So my main concern right now is to try to understand what is the condition you have in the field and try to understand what can we do. Uh, some of the fields that I have been visiting with them, we have these sediments that are cracking all the way and all around. Some of them much more in the silt side, some of them much more in the sand side of the soil spectrum. So in each of these fields, we should expect to have things happening in a very different way. And Forbes already mentioned as well. Some of them we may have herbicides. Some of them we may have some source of debris that we do not know what they are and how the plants are going to grow. You can see here in my first picture, we have nothing growing up. In the second one, we have a few plants that are trying to germinate. Some of them, they germinate and later on they die. So I like to say that at this point, we still have more doubts and more questions than truly answers to talk to you all. So another thing we learn with this is even some of the areas that, you producers work in the area and try to level it up and bring it back to a scenario where you could plant later on. We also found out last week that some of these areas were flooding again. So we do not know at this point how stable those areas are, and you need to have cautions when you're working in these areas. So on the greenhouse studies, I think you guys will be able to see this. I wanted you to see, this is I think Forbes already showed this picture as well, where we have the place where we had the sediment there, and we didn't have anything growing there, right? So I took a video out of this, and I wanted you to see this. Can you hear this? So that thing can be solid, right? And that's kind of the concern we have. Some of these areas will be tough to work with. Some of these areas will be really tough to drill seeds in. These are the two main plots here that I'd like to show. Forbes mentioned a little bit. You have here tall fescue, and we truly didn't have much here. The second one here on the orange square, you can see the orchard grass. We have a few plants coming up there. And that's the scenario, right? Again, very solid. And as we're working on this, it's tough to expect something to get out of this. He already mentioned to you that we found that some of the soils we do have organic matter, but we do not know for how long they are going to be there, right? I think the main challenge will be to find a way to bring back the structure of the soil. Right now, we have a bunch of sediments that was deposited there, and we don't have really soil structure around this. So what we did as well was understanding that fescue was not doing great and even orchard grass, we came up with a second try where we increased the seeding rates. And by increasing those seed rates, 1.5 to 2.5, 3 times the seed rate, we got more out of them. It does not mean that we are going to have a really good pasture. And that's the kind of statement that I want to make clear tonight. We are talking here about recovery areas. We are far from recovering the pastures as they were a year ago. It may take us a year, 2, 3, 4, 5, depending on the level of the sediments you have there and how bad was the situation in each of the fields we are talking tonight, that it may take years to bring it back to the levels that we had in the past. So if we pull some of the pictures here from the tall fescue, you can see that as we are trying to pull some of these plants out of the trays we had there, Forbes already mentioned it. We got that crust, very, very tough crust on the top. And you see in the third picture here, I'm squeezing that thing and I could not crush it. So if you see, we have here a small fescue seedling trying to make through this, and see how much the plant has been spending in terms of energy here to make through this. So a lot of the seeds that we are going to put on the ground in these kind of scenarios, we need to take into consideration that some of these seeds will never make through. So increasing seed rate is one of the things we need to think about when we are trying to recover those pastures. Here already mentioned, right? Annual ryegrass, oats, and wheat. Those were the 3 plants with bigger seeds that we saw them making better, that we saw them bringing us a beautiful plant, that we like to see the plants and say, yes, I can trust in a plant like this. So here I brought to you annual ryegrass, the first one, and in the place we were able to cover with a straw or old hay, because that's one of the concerns we had as well, was what are you guys going to do with the hay that was flooded, right? That was underwater. We don't want you to use that hay to feed animals anymore, but you can use that hay to spread it there and try to bring some organic matter back to those areas. And also some nutrients that are still in that hay, in that moldy hay that was underwater there. So with oats, pretty much the same. We could see good plants here, healthy plants that we could trust that they will help us to try to, repopulate these areas. In the place we didn't have the sand, the straw, you see, basically we had the sand here. The plants were smaller. The plants were kind of yellowish. So bringing back organic matter and bringing back some of this old hay there will help us on this. And finally here, the wheat, the last but not the least, right? I already mentioned annual ryegrass, oats, and wheat. So wheat will help us as well. You can see here pretty much the same thing. One of the concerns I have, now I'll come back a little bit here, just remember about this, is the annual ryegrass. If you really want to have it back in tall fescue or in orchard grass, annual ryegrass may not be the plant to use because it's very high in terms of competition. So annual ryegrass is always growing faster and better than fescue and orchard grass. So you don't want to build a bank of annual ryegrass there if you really want to bring it back to fescue. But it may be helpful at this point. So again, oats and wheat. So what I put together here was what I'm calling a recovering plan for pastures. And as we have been working with these areas and realizing how challenging it can be, we don't believe that we are going to just bring it back fescue, right? We are going to go step by step and rebuild these areas. So for the spring now, assuming that the window we have from February to April here, we can work with oats and annual ryegrass. Those are the 2 options we have right now that will help us to have something to graze, or as Forbes mentioned, to at least hold the river banks. At this point, that's kind of the concern we have as well, to have some sort of plant growing there that will help us to hold this sediments there and kind of help us to recycle the soil and bring it back to life. If you cannot do it during the springtime now, February, March, April, because we don't really know how it's going to be the conditions in those soils to be able to plant anything. Some of them are still, as I mentioned, I show pictures with some source of water standing there. But if you can, oats and annual ryegrass would be an option for the springtime. If we think about the summertime, when we are more in a transitional phase, if we can, we do believe that those plants will be able to help us there: crabgrass, sudex, and soybean. Those 3 plants, and when we talk about soybean here, I'm talking about soybean with forage proposed, right? I'm talking about grazing those areas or harvesting those areas if you can. So crabgrass, Sodex, and soybean will help us to bring plants to this area that we have deep root systems. Soybeans will be, helping us with some source of nitrogen as well, because those legumes will be able to fix nitrogen. So we believe that if we can put together a mix that will have crabgrass, Sodex, and soybean, those 3 plants will help each other to make through that crust and grow roots and in some way bring some green back to these fields. If you're going to mix them and plant them together, at this point, we don't have a recommendation in terms of seeding rates, but assuming the challenge we saw in the greenhouse, I'll try to keep the full rate in all of them to make sure that you have seed enough to make through that crust and to disaggregate those sediments in the top layer that we have in the field to be able to. Again, is it the best way to do? Is it the least, the least expensive way to do? Probably not. We may need to spend more money in these areas to make sure that we are going to be able to grow something there. So if you can make it through the spring with oats and annual ryegrass, and then make through the summer with a mix of crabgrass, Sodex, and soybean. And we will having trials with this along this spring and summer. So we'll be able to bring back to you some results while we are going and working with them as well. If you can make it through spring and summer with them, what we expect you to be able to recover this soil at a point that we may be able to get into what we are calling phase 2, where we are going to bring back the perennials. Because that's what we need, right? We need perennial grasses taking care of these sediments to be able to use them as pastures again. So if we are going to do this, we have 2 ways to do this into the next fall. If you want to bring back fescue, knowing what we learned with the greenhouse trials, we know that we need a companion crop. We'll need to have something like wheat that you are going to bring it with half rate. That's the reason I'm putting here from 60 to 9, because from 120 to 180, that's the full rate to plant wheat. So we can come with half the wheat rate, associate it with, I would say, with full rate of tall fescue. So try to put together 20 pounds of tall fescue with something from 60 to 90 pounds of wheat and plant it together. Those wheat seeds will help us to make through the crust and populate the pasture in the very beginning, and then tall fescue will come behind the wheat, trying to make sure that we are going to have an annual and then a perennial that will persist and will actually be growing for us in the spring of 2026, right? We're going to plant it in the fall of 2025 to be able to have pastures in 2026. If you want to come with orchard grass, if that's your goal, again, you can go with a full seed rate of orchard grass, but we need to bring oats with it. So from 50 to 70 pounds of oats with 15 pounds of orchard grass will help us to make through the crust with oats and, make that top layer a little bit more fragile so the orchard grass then can make through, and then we're going to be able to bring back again a perennial grass with an annual grass in 2026. I think that the final message I have here to wrap up this presentation so we can discuss a little bit is how we are going to do this, right? If you think you can run a drill, great. I used to say that drill is always better than broadcast. I don't think we are going to be able to drill seeds in most of these fields yet, right? Hopefully through the spring and summer, we will find people that will be able to do it. We already found people that did it. And again, don't push yourself too much. Don't think that's going to be perfect. Don't think that's going to be the best pasture you ever planted. We are talking about recovering areas here, not to establish a beautiful pasture. The second option we have here is broadcast. So if you're going to run a drill, try to broadcast it. I always like to recommend increasing rates when we are broadcasting. So especially when you get into the second phase, when we're talking about perennials, if you are still broadcast seeds, don't save money on seeds. That's what we cannot do. We need to make sure that we have seeds enough there to plant those pastures as they are coming back in the next fall. The third option here is to use drones. We don't have it a lot, but we do have some. We have people already working with drones and providing services on this. We have been talking with a few guys here in Tennessee. I know that our colleagues in North Carolina have been using it as well. The last time we heard about this, we learned that they are charging from $20 to $25 per acre. And a drone like this can cover up to 200 acres in a day. So it may be a good option to be able to get into these fields without need to bring a tractor with you. And I think that was my final message. I will leave here my contact as well, my email. If you guys have any kind of questions, I think we could try to answer them from now on. Forbes, what am I missing?
I mean, our other partner in crime is David McIntosh. I don't know if we've missed anything, David. You've obviously been involved with this work, heavily involved with this work as well.
I think the biggest thing is I just keep thinking about, in the greenhouse study, we mimicked, rainfall. We mimicked hard and soft, different events. And basically that's where we saw the crust forming. I think that's the only thing I'd want to mention a little bit more about.
Okay. With that, if we have any questions, you got two options. You are welcome to unmute yourself, which if I remember correctly, press your space bar. That would temporarily unmute you if you have a question you'd like to ask, or you're also welcome to type it in the chat box. So if you have a question, now's a great time to get our specialist to answer it.
I will also add that we recently received funding from the Department of Agriculture that's going to fund a couple of graduate students, as well as our ability to work on some farms. And so we've already identified some farms in the Irwin area that we hope to be able to do some of this work with, these trials, and then hopefully have field days to show this is what we tried and this is what's working and this is what's not working. And so we obviously want to, keep everyone in the loop to understand what's, what we're being successful at. The other thing that we have learned, and maybe David can mention this, that we've learned that the Farm Bureau, Tennessee Co-op, as well as the Cattlemen's Association have pots of money that they were planning to help do some of the revegetation work. We've given them some caution. They hadn't realized, what kind of work that we'd done. Once we've shared it with them, they said, okay, yeah, we need to be working together. So there is, funding available. We want to make very good use of the funds. We don't want to do stuff that we know is not going to work. And hopefully, as Bruno says, this is not going to be a quick fix. It's going to be, our earliest that we can hopefully get some pastures brought back to life would be in a year's time. But that's going to be a challenge.
Perfect. Thank you so much, Anna, for the opportunity to be here. I just want to let them know that we are still working on this. And as soon as we have more updates, we can have another webinar like this and share with you all.
Well, thank you. And I would think, as we especially get closer to fall seeding, that would make a lot of sense to see what's been borne out from the spring and then summer seeding.
Yeah.
All right, everyone. Have a good evening. And wherever you saw about this meeting before, whether it was on our Facebook or the Forage Program's Facebook, keep an eye out for future options. Thank you all for joining us.